Good morning, everybody. I wanted to share a different approach to this problem that caught my interest. It's from a regional Math Olympiad, 2011, the country of India. They call it RMO for short. But I just like the nature of the problem here. It was kind of interesting. There's some symmetry going on. It's an exponential, and I just like the look of the problem. And I messed around with it a little bit trying to solve it directly, and I thought, well, maybe let's look at it from a standpoint of where the solution would exist. All right, and then see if we can use that to leverage the answer. Also, this turns out to be a function of two variables. So if you could actually graph this in 3 dimensions, a function of two variables has a 3-dimensional graph. You could somehow other sketch critical points on that might be towards the answer. But for now, we'll focus on where the answer is not. Now, you can see the claim there. I'm claiming that if AB is an ordered pair solution to this equation, then A and B both have to be trapped inclusively between -1 and 0. Now, rather than go through a rigorous proof, I'm just going to go through the justification for the claim. Right here, it reads if both A is greater than or equal to 0 and B is greater than or equal to 0, which is to me kind of a clumsy compound inequality, then the left-hand side of the equation has to be greater than or equal to 2. Now, that's not particularly difficult to see if you work at the endpoints. If you put A equals 0 and B equals 0 simultaneously, you get 16 raised to the 0 power plus 16 raised to the 0 power, which is any exponential base raised to the 0 power is equal to 1. So that's greater than or equal to 2. That's easy to verify without writing it all out. In a similar fashion, if you check these endpoints of this compound inequality here, you're going to see that you also get the same result. It's you have a squaring operation going on, and you'll get 16 to the 0, 16 to the 0. So what we know is no solutions could exist in either this region or this region right here or this region right here. Now, I've been noticing that some of the people that present problems on the math YouTube channels work with the membership operator to represent compound inequalities. And what I'm specifically talking about right here is this, what they call negated relation. That the little, I guess, vertical slash through the Greek letter epsilon means not a member of. Okay, so that symbol right there that I've highlighted means is not a member of. So we're telling you where the ordered pair could not exist. Now, from a standpoint of set theoretic complements, the complement of that set is A comma B would have to be between -1 and 0. And again, this is what they call a negated relation, not a member of, not equal as a negated relation. This is the more common way. I've seen Dr. Michael Penn write his compound inequalities this way, and I like it. It's very direct. It says if there's a solution to this equation, it has to happen between -1 and 0 because it's greater than or equal to 2 everywhere else. Okay, so that's really the reasoning behind this. So that's not that difficult. All right, so we kind of reduced the size of the haystack here. Now, if you come on down with that knowledge, it makes sense to try some multiple of 2, since 16 is equal to 2 to the 4th power. Now, this isn't really a multiple of 2, but I picked -1/2 because -1/2 is in this interval. -1, the ordered pair -1/2 -1/2 satisfies this condition. Now, and you can do the arithmetic on it and see that it comes out to 1. I've tried to detail that for you right here. But notice here, and I know there's people that'll say, well, you haven't proved it's the only solution. You're right, I haven't. That's why I used A here. All right. A means not unique necessarily. If I'd put in a V there, then you guys could, that would be red meat for all the people that look for mistakes on these type of problems, you know. And again, I'll be a little, let me write that down. I used, let me see if I can figure out how to use this Zoom stuff here. Okay, folks, right here, A, not B, was specifically chosen. Now, you guys know, all of you have friends who are English teachers. The connotes a unique solution, the solution. And right here, I intentionally put A just to keep the semanticists, on their toes or not be attacked. But anyway, so all I know at this point is that -1/2 is a solution. There may well be others. I sort of doubt it. I think there's some way you can show that function of two variables. If you think of this is a function of two variables up here. Can I highlight this? Stop that. I got to get out of this, I guess. But all right, y'all, I'm not going to delay you, but if you think of that original function as the function of two variables, then it's probably increasing in some sort of way. And so -1/2 is probably the only solution. So it was a guess and test, but it was an educated guess and test. Appreciate you watching. Thank you.